Psychologists transform their scientific attitude into practice by using the scientific method. They observe events, form theories, and then refine their theories in light of new observations. So to determine facts and control the possibilities of error and bias when observing behavior, this is why scientists use the scientific method, in psychology in particular. Okay, so in order to talk about the scientific method, we need to understand the difference between an experimental group and a control group. First, we'll talk about an experimental group. An experimental group is the group in a scientific experiment where the experimental procedure is performed. This group is exposed to the independent variable that is being tested and the changes observed and recorded. So let's say that at your school there's a problem with hyperactive students after lunchtime. They are very inappropriate in class, they talk out of turn, they can't stay in their seats, they're off task. And so in order to try to understand why this is happening, teachers and administrators are starting to observe what could possibly be happening at lunch that is causing this disruptive behavior. They are noticing that an abnormally large amount of caffeine is being consumed by students during lunchtime. And so let's say that they decide to do an experiment to see if caffeinated beverages are a cause for the hyperactive and off-task behavior of students after lunch. So in this experiment, our experimental group would be students that are consuming caffeine, caffeine being the independent variable. So in this experiment, we need to have a control group. A control group is separated from the rest of the experiment, where the independent variable, in the case of our experiment, it would be the caffeine, is being tested, so that the independent variable cannot influence the results. Okay, so this isolates the independent variable's effect on the experiment, and it can help us rule out alternative explanations for the experimental results. For example, if we find that the control group is having the same hyperactivity and off-task behavior, we know that because the independent variable, or the caffeine, has been isolated from the control group, that the caffeine is not the issue with the student's behavior after lunch. Okay, so also in this experiment we have what we call placebo, and oftentimes this is something that is given to the control group. So it is inactive substance or condition that is sometimes given to those in a control group in place of the treatment given to the experimental group. And in this case, if we were to perform this experiment, we would perhaps give the experimental group either caffeinated coffee or caffeinated beverages of some kind, and we would give the exact same beverages or coffee minus the caffeine, so we'd give them decaf as the placebo. Now what happens often with this is we experience the placebo effect. In the placebo effect, often those that are given the placebo will experience symptoms given to that the experimental group will experience with the actual substance, in this case caffeine. They might think that they are actually getting caffeine, and as a result they might exhibit that same hyperactive behavior, thinking that they are actually getting caffeine, and they will feel the symptoms of caffeine even though they're not actually getting caffeine at all. This is called the placebo effect. Okay, so we're going to talk about the steps in the scientific method. And so we will go through them each one at a time individually, but these are the steps. We have the theory, we form a theory, a hypothesis, we test the hypothesis, we draw conclusions, and then last of all we report the results of our experiment. So these are the basic steps of the scientific method. Okay, so first let's talk about theory. Okay, so a theory explains and organizes and predicts outcomes. So this is something that in a theory we have something that we observe. We observe behavior, and so A useful theory will effectively organize a wide range of observations, and it implies testable predictions called hypotheses. So let's say that we are interested in finding out if caffeinated beverages cause hyperactivity in students. We observe that many of the students are drinking caffeine at lunch, and they tend to be rather excited in class after lunch. So our theory may be that caffeinated beverages are likely the cause of hyperactive behavior in students after lunch. This is our theory. We try to link the two. Next, we form a hypothesis. Now, a hypothesis must be a testable prediction. Often it's called an educated guess, okay, about how things work. A hypothesis should be something that can be tested. For example, let's say that these students are hyperactive during lunch, and we want to see if caffeine is the problem. So we have to figure out ways in which we can test whether or not the caffeine is causing the hyperactivity. So we are going to test this hypothesis. This is designing a measurable experiment, or it can be a survey. Okay, so it's going to be something that we will try to put to the test to see whether the students are hyper or not. Now this becomes a problem because we have to define what is hyperactivity. What do we define as off-task behavior in students? So in doing this, we come up with operational definitions. These are very important in defining what is the outcome of our experiment, or what in our case is off-task behavior in students. So we need to know, we have to have a very clear and precise explanations of the items being measured. In this case, off-task or hyperactive behavior in students. So the operational definitions also describe exactly the variables, what they are, and how they are measured within the context of the study. So it's very important to understand what the operational definitions are and to make those very clear before the study. Okay, so an example of this, we need to define hyperactive behavior as perhaps being whether the student is talking out of turn. That might be one of the definitions. Students can't stay in their seat. They're wandering around class. They're fidgeting and moving their pencils and shaking their legs, and they can't seem to sit still in their seats. They have an inability to remain focused on their work. These might be operational definitions that we would use in our experiment. And of course, we would need someone to record and observe the student's behavior in order to measure it, to see how often they are displaying these types of behaviors during the class period. Okay, so in doing this, we are coming up with correlation. The correlation is a measure of the extent to which two events vary together and how well either one predicts the other. In this case, is there a correlation between the amount of caffeine consumed by students, or if they consume caffeine, and whether they are on task in class or not, if they are hyperactive and off task? So we're going to see in our experiment whether these two things correlate. So what we're doing is we are seeing whether coffee or caffeine or Red Bull or whatever kind of caffeinated beverage students choose to consume plus students equals hyperactive behavior or off-task behavior in students. We're going to see if there is a correlation between the caffeine and the students being hyperactive. Okay, so next step is we are going to draw conclusions. This is step number 4. We're going to draw conclusions. In this, we are going to organize the data that is collected during the experiment, the numbers, the amount of times that these students are caught off-task and off-task behaviors and things. We're going to organize the data to determine if the hypothesis was right or wrong. If it is wrong, then we have to go back and come up with a new theory and start the whole scientific process all over again, the whole method all over again. Regardless of if we are right or wrong, The next step in the process, step number 5, is to report the results. So others can then learn from what we have experimented on. They can perform the same study, or they can avoid the same study if it didn't work, if they choose to. But the results will help those behind us that are going to try to learn about the maybe effects of caffeine in the classroom as well. Okay, there are other types of scientific study. We have naturalistic observation is one of our different types of scientific study. We have this is it records and describes behavior in a natural environment. Okay, these naturalistic observations may describe parenting practices in different cultures, student self-seating patterns in American lunchrooms, or it can be chimpanzees' family structures in the wild. Or in this case, we can observe socialization of baby gorillas in their natural environment with their gorilla families. Case studies. Case studies examine one individual group in great depth, or individual, I guess, in great depth, in hope of revealing things true of all of us. Some examples are medical case studies of people who lost specific abilities after damage to certain brain regions. And this gives us a lot of knowledge. It has given us a lot of early knowledge about the brain. All right, so intensive case studies are sometimes very revealing. They often suggest directions for further study, and they show us what can happen. But individual cases may also mislead us. The individual study may be atypical or not like the larger group. And so in viewing such cases as general truths can lead to false conclusions because everyone is very different. And some cases, some individuals have very, very extreme situations. So there are some problems with case studies, but they have been very helpful. Another method that we have is the method of conducting research in the form of interviews. It can be in person or on the phone or through the internet. These are typically called surveys. A survey looks at many cases in less depth and asking people to report their behavior or opinions. Questions about everything from sexual practices to political opinions are put to the public in recent surveys. Okay, so now we talk about sampling. Okay, so we have, this is the way that we determine the people or the population that are going to be tested or experimented with. So one effective way is random sampling, and this is when we have a randomly selected sample of subjects from a larger group or population that participate in our survey or experiment. So if we are going to do a representative sample at our school, let's say we have about 1,500 students at the school, we might have a random selection of 200 students that we actually have participate in the study. We just randomly select them from various ages and classrooms and grades in order to participate in the study. And these students will represent the larger population of the student body at the particular school. We also can do the population. With the population is the entire group being studied. Okay, so we have, it can be an entire group of people or animals which researchers are interested in.